Alright, so what we're going to look at now is the partial sum of an arithmetic series. So it changes from a sequence to a series if we start adding up the terms. So looking at the original sequence that we had, 4, 7, 10, 13, 16, etc. Summing that series means doing 4 plus 7 plus 10 plus 13 and however many terms you need to do. The n still works as it did when we said t to the n, okay? So what we're going to try and come up with is a general rule for the sum of a series to the nth term. So we know that the sum of m is t1 plus t2 plus t3 plus t4 all the way up to plus tn. All right, but think about that. What does that mean? Well, t1 we know is a, okay, and then t2 is a plus the common difference d, and then t3 is a, that first term, plus 2 common differences, and it keeps going on in that pattern until we get to this last term, okay, which I'm going to call L. But if we think about it from the opposite direction, we say the sum to n, well that's Tn, which is the last term, plus Tn minus 1, the second last term, plus Tn minus 2, the third last term, all the way back down to T1. All right. So when you do it that way, what you have is the last term plus, and we have that last term minus the common difference. And then the next term is the last term minus 2 of the common differences. And we continue on that pattern until we get all the way back to the first term again, which we call A. All right, so I'm calling this equation 1 and this equation 2. Now have a look at those equations. We've got A's, we've got L's, and we have D's. In equation 1 we have plus D's, and in equation 2 we have minus D's. So what I'm going to do is do equation 1 plus equation 2. Alright, so start at that first. You have a look top and bottom. What I've got is an A and an L, and I'm adding them together. And then it's going to happen for the second one as well, because when I do that plus that, I'm going to have A plus L, but then the D minus D is going to disappear. And then what's going to happen with this third pair? Well, we're going to end up with A plus L. We've got 2D minus 2D, so the D's disappear again. So we're eliminating one of the variables if we follow this pattern. Okay, so that's why we're going to add them up. But anyway, back to the start. We've got Sn in equation 1, we've got Sn in equation 2. So what we have is 2 Sn, so 2 lots of the sum of this series to the nth term is equal to, and we just went through the pairs, right? So the first pair is A plus L, and then the second pair is A plus L, and then the third pair is A plus L. And that's going to continue on until you get to the last one. Now, how many pairs do we have? Well, there are n terms, so we have n pairs. So 2Sn is equal to n pairs of A plus L. But that's 2 times the sum of the series to n, and I only want the series, so I just divide it by 2, and I get the formula n over 2 outside of A plus L. So the sum to the nth term is n divided by 2 outside of the first term plus the last term. Now that's wonderful if we know what the first term and the last term is. If they say to us add this series up to the term 200, great, we can substitute that in and that's fine. But what if they don't tell us what that last term is? What if they just tell us how many terms they want us to sum up? If they tell us the n but not the L? Well, what we do is we say, we know that that last term, t to the n, is equal to A plus n minus 1 times d, don't we? And that's going to be the last term in our series. So I take that and I substitute that equation into here. So Scn is equal to n over 2 outside of A plus, and then it's A plus n minus 1 times d. A lot of brackets there. Now let's just tidy that up. Well, everything still has the n over 2 out the front. Okay, and then we've got a plus a. So now I have 2 a's plus, and then we've got the n minus 1d left. So that's another equation that we can use, or another formula that we can use to sum the series up to the nth term. And this one we can use if we don't know what the last term is, but we do know what the common difference is. So they are 2 more for your formula sheet. So write those down. You need to know both versions of that because the information they give you in the problem could use one or the other. So pause the recording, put that onto your formula sheet, and then come back and we'll have a go at this exercise. So we're being asked to evaluate our formula, evaluate our series up to the term 121. Okay, so we know the first term. First term is 4, and we know the last term is equal to 121. So if you go back to our formula, we've said that Sn is equal to n over 2 outside of a plus l. So which of those variables are we missing? We don't know n. We don't know how many terms there are. So what we're going to do is use this 121 to work out what n is. So for that, we need our Tn to the formula. We need our Tn formula. So start off with your a plus n minus 1 to d, and we've worked out what n is in the last exercise. So we put in 121 is equal to 4 plus n minus 1, because we don't know what that is. And that's times 3, so it's 117 equals 3 outside of n minus 1. So then we get 39 is n minus 1, and so n equals 40. Okay, so now that we know what n is equal to, we can substitute that back up into our formula here. So it's the sum to 40 is equal to 40 over 2 outside of the first term, 4, plus the last term, 121. And that just goes straight into your calculator. It tells you that the sum of the terms up to 121 is 2,500. That's how we use the first formula. So for this one, it's changed a little. Instead of asking us to find the sum, they're giving us the sum. They're telling us that that sum is equal to 8,625. And what we have is 4 plus 7 plus 10 plus 13. So what do we know? Well, we know the first term is 4. We know that the difference is 3. We're asked to find n, and we know that the sum to n is equal to 8,625. So we can't use the formula we used last time because we don't have the n and we don't have the last term. I can't use a formula with 2 unknowns. So we're going to have to use the second version of the formula. So Sn equals n over 2 outside of 2a plus n minus 1 times d. It's very similar to our Tn formula. Okay, so it's not that hard to remember, hopefully. Now let's start substituting in. So we know that 8,625 is equal to n over 2 outside of 2 times 4 plus n minus 1 times 3. That's getting pretty familiar by now, I hope. Now I've got a fraction. I don't like solving equations with fractions, so I'm going to double it, get rid of my fraction from the start. All right, so 17,250 is equal to n. Now let's have a look in that bracket. 2 times 4 is 8 plus, and then I'm going to expand this second bracket out, 3n minus 3. Okay, now have a look at the right hand side. We're going to tidy that up because we can't do much with this equation. We've got our n, and then we're left with 3n plus 5. Well, look at that. Remember all that quadratic stuff that we did? This is why. So expand out your brackets, 3n squared plus 5n, and then you're going to bring that across to the right. So what we have is a quadratic to solve. 3n squared plus 5n minus 17,250. Now, if these were smaller, nicer numbers, you would use your cross method or your product sum factor method and factorize those. But at this point, we don't expect you to be able to factorize 17,250. And if you're in an exam situation trying to come up with factors for that, it's just not going to be pretty. And there's no point. There's a quadratic formula. So substitute it into your quadratic formula if you need to. Okay. What you're going to end up with is that n is either equal to 75 or it's equal to minus 76.6 repeater. But we've talked about this before. N can't be negative. N can't be a fraction or decimal. N can only be whole positive numbers because it's counting the number of terms. So what that tells me is that n must be equal to 75. Alright, so here's some new notation for you, the sigma notation. Hopefully you've encountered that in the junior school, but if you haven't, as a quick run through, what that means is that we want to add up 5n minus 3, substituting in all the values from n equals 1 to n equals 10. Okay, so what that means is that when you start substituting in, you first go n equals 1. Well, when n equals 1, 5n minus 3 is equal to 2. And then we do n equals 2. So 5 times 2 minus 3 is 7. And then we keep going, and we do that up until we get to n is equal to 10. So 5 times 10 minus 3 is 47. So we want to know the sum of that series, starting at 2, going up by 5s until we get to 47. What does that sound like? Hopefully you're able to recognize that that is the sum of a series. So your first term is equal to 2, your difference is equal to 5, your last term is equal to 47, and n, the number of terms, think about it carefully, if we're going from 1 to 10, the number of terms is 10. So for this one, you can choose which formula you use. We've got all the information we need for both. So I'm going to go with the simplest one, which is n over 2 outside of a plus l. But you can use the other formula if you forget this, because we've got that information. So the sum to 10, the first 10 numbers of this, is 10 over 2 outside of 2 plus 47. So the sum of that series is equal to 245. Seems straightforward? Have a look at the next one. Exactly the same algebraic expression, 5n minus 3, only this time we want the sum from 10 to 20. So if you were given this question, you'd start it off the same way. You would say, well, what's the first term going to be? Well, that's when we substitute in 10, so 5 times 10 minus 3 is 47. And what would your last term be? Well, the last term is going to be 5 times 20 minus 3, so the last term is 97. And here's the kicker. What's n? Now, everybody wants to go 20 minus 10, so it's 10. But I want you to break your fingers out and start at the number 10, because remember we are substituting in 10, and count all the way to 20. How many numbers are we substituting in? N is equal to 11. Okay, so here's a trick. Whenever you get one of these sigma notations, what you want to do is the top minus the bottom plus 1. Now go up and double check. If in that first one at the top of the page we went 10 minus 1, we would get 9. But there aren't 9 numbers from 1 to 10, there are 10. You have to remember to add 1 back on. Okay, it is a trick that catches people quite often, and if you put that wrong n in there, this whole thing's missing, because the whole thing's wrong because you've missed a term. Okay, other than that, it follows exactly the same thing as above. The trick is getting the n right. So the sum is going to be equal to, there's 11 terms, so 11 over 2 outside of, my first term is 47 and my last term is 97. So that sum is going to be equal to 792. That's what you need to be able to do the exercise. Good luck, and I'll see you in class.